Hey, welcome to a new episode of SDV Coffee Talk. Today with two amazing guests from Siemens, Robert and Hans-Jürgen. Just a small disclaimer from my side. Everything what I say here is my own opinion. It has nothing to do with my employer. Let's start. Do we want to have a short introduction, Robert, Hans-Jürgen?
Sure.
Do you want to start? Let's
Good
go.
evening to everyone. Thank you for having us, Fatih. Robert Woll from Berlin, working with Siemens as a pre-sales technical account manager for our automotive customers. So over the past 9 years that I'm with Siemens, I've been in service and pre-sales, mostly for automotive OEMs, and since of lately also for our tier suppliers. And just to get a little bit of an idea where I come from, what my background is, I studied computer science, so I have quite some background in software development, but afterwards I specialized on software for engineering and worked at a research institute, Fraunhofer Society, where I did my PhD, and my focus topics were systems engineering and data integration. And so my background in the later years as of now were like mostly systems engineering, and I'm more like a generalist now. While I can go in more depths in systems engineering, mostly I'm more of a generalist and trying to look how software, mechanical development, of how everything fits together in the development processes. And this is what I'm going to address today. And with this, I hand over to Hans.
Hello, everyone. Fatih, thanks a lot for inviting us today for the coffee talk. I hope, I need to excuse myself for not drinking coffee at this time of day, but it's great to be here because I think SDV is a very sophisticated and important topic, and it's great to be here to discuss about that. So I'm like Robert, I'm also with Siemens. I'm with the company now since a long time. I started with Siemens Automotive, then went to Siemens AG to do a lot of wiring harness engineering and architecture design. Then spent some time at Siemens VDO designing network design tools and architecture trade-off solutions, and was part of the AUTOSAR consortium back in the days when it was founded, which is you can tell how old I am because I was one of the founding members of the AUTOSAR consortium. Then Conti bought Siemens VDO, so I moved to Conti, and then after some years I went to Mentor Graphics, where I was responsible as product manager for developing an AUTOSAR stack, network design solutions for automotive, and via Mentor, I came back to Siemens, where I do mostly business development around the topics of model-based systems engineering and software-defined vehicles, where all the background that I have in network software, electronics, electrical design helps a lot, because I think software-defined vehicle is a holistic topic. It's not only about software, I guess.
Thanks. Today's topic will be SDV is not about software mostly. This is what we want to talk about. Probably you can first start actually with how Siemens entered this field. I've never heard actually Siemens and SDV together. Probably you can just give us some short introduction to how Siemens come into picture, so to say, with SDV. I was not aware about that. I'm in this topic for a couple of years already, but never heard Siemens actually.
Right, good question.
So it's a bit like Siemens has an AUTOSAR stack, right? We have an own AUTOSAR stack which is in use and in many cars out there. I can mention a couple of brands like BMW, like Volvo, where we have press releases around that, right? So we are in the automotive industry since a long time, and we have started looking at software-defined vehicle and the projects because partner companies basically asked us to join in on these discussions, like Microsoft, for example. There was an event in the company that you work for, where we basically got in touch for the first time. We work on the Horizon project by Google, which is also around SDV. So we are engaged in many different areas, simply because our clients, our customers ask us, well, you have solutions in application lifecycle management, you have embedded software, you have network design tools, all these different aspects of the implementation level. And as software-defined vehicle requires to transform or to transition from 120, 150 ECUs to something more consolidated, it basically touches all of these aspects of the design flow, right? Electrical, network, communication, software architecture, and that's basically where we have been called in. And I agree. Many clients or many companies are not even aware how deeply engaged we are in the automotive industry. But it is a fact, right? And there's a lot of cars out there which are using our technology and our solutions.
Interesting. Robert, do you want to add something, or?
It's just a general remark, maybe. I mean, the core part of our strategy is to have a very comprehensive portfolio to support the entire development process, not only for cars, but also for aerospace, defense, and other industries. So most of us know us probably for CAD and PDM, PLM systems, but with the acquisitions over the last time, most of these acquisitions happen to complete the coverage of all the relevant processes across product development, all the engineering processes, manufacturing aspects, and to bring everything together, right? And then software is there for a long time, EE is there for a long time. And as you know, Siemens had a lot of acquisitions and mergers with other companies, for example, Mentor, to get more depth in the EE field. And now we partner with IBM to get more depth in the software field. And I think Hans-Jürgen will talk more about it. Just wanted to underline that since software development is part of overall engineering and it has to fit in there, it must be in our portfolio. We must cover it if we stick to our strategy.
Okay. Probably we can just start the discussion a little bit in this direction of our topic. What do you think about the common trend, what happens in automotive at the moment in the industry? I mean, there are many buzzwords at the moment. SDV is one of them, and also AI is also in context of this is used a lot. What is your perspective actually? How do you see this, the changes in the automotive industry from your perspective as one of the biggest companies of the world?
Oh, I mean, it goes into many different layers of how you design and also manufacture and operate vehicles, right? It's not only about we put more focus on software. It's also around we are using or we are building new architectures in the vehicles, like zonal architectures, for example, where you're replacing tier one delivered hardware software bundles into something where you have a high performance computer, which requires different technology for the chips that you're actually using. That's where our Mentor Graphics chip design know-how and capabilities really helps to predict what is going to happen if you're using a 16-core ARM-based microcontroller with this amount of AI capabilities, for example. Will it be enough in order to deliver the performance that you need? Very simple. These are the type of questions that we help answering. But I think the overall ambition behind SDV is not we're doing it because it is nice and easier, but it's also in order to give new value to the customers of the car companies, like to you and me, right? So to enable us to get functional upgrades after we purchase the car. Something that we're very used to in mobile phones, that we're very used to with computers, right? But to establish this whole new business model, to establish the whole over-the-air update capabilities is not a simple transition, but it requires many companies to reinvent themselves. And this is something that we help doing by providing advice on how to establish CI/CD processes, how to orchestrate them, how to integrate the design and the workflow. And I think that's important. It's not only about, well, we changed the way how we build vehicles. It's also about we do that for a purpose, and the purpose is there in order to make the vehicles more attractive to the end user and to the end customer. And so this transition is not simple and it's not trivial, I guess, or for all car makers.
Okay, Robert, do you have?
Yeah, I mean, Hans-Jürgen mentioned it. I think the keyword like zonal architectures. I think it's a lot of work is happening around the reusable architectures. Reusable, mostly when they mean reusable architecture, we're mostly talking about the EE architecture and sensors and actuators, where they're located, and to have that somewhat reusable as a part of the platform.
Okay.
In the past, the platform was very much a mechanical platform, and now the importance of the electrical and software platform becomes much more getting much more important, and this is leading to a situation where you have different life cycles. I think that's one of the big challenges that we're seeing. You have the typical vehicle development project, then you have the platform that's maybe developed within one vehicle project or outside, but that's certainly going to be used across multiple different vehicle projects. And then you have the software that's partially being developed against that architecture, but has to be tested in the context of the project. So it's very complex. So where in the past we looked at maybe one life cycle, we now have at least 3 different life cycles, and we need to constantly align them. And I think this is what many are currently struggling with. I think many people are still stuck in this project development process, trying to fit in everything there and talking about how we can shorten the product development process when they talk about the vehicle project. But there's the software development process and the platform development process as well. And I think we need to look a little bit more at how we can combine these 3 life cycles to speed up everything, right? So this is one of the big challenges.
I mean, in this context, if we talk about this architecture and very technical stuff, actually, there's definitely a change in this technical stuff. But if we consider this from the perspective of the customer, if I'm a customer of, and what does it mean actually for me having an SDV? I mean, what are the customer value actually I get from SDV compared to a usual car? I mean.
Oh, and I can give you a good example. I mean, for me, it means that I can order a new functionality for my car via my mobile phone. It means that if the car manufacturer offers a new capability, like, for example, a black box, which helps me in the case of ever having an accident or something, that it records the last 60 seconds, next 60 seconds before an event, I can book that as an upgrade, as a functional upgrade. After I ordered the car, after I have the car, a year after I received the car for the first time. Something like a radar warning system that is activated in every country but Germany, because they're not legal to have in Germany, but in Italy or in Austria, for example. So that is something that can even be much more sophisticated. To give you an example, when I ordered my car, the motorway assistant of the car manufacturer that I bought my car from was not available yet. If I would have ordered the car 1 month later, I could have ordered it as part of the package that I get, like as an option. Right? And now I'm just waiting for it to be available as a kind of after-sales upgrade. And I will be very happy to buy that, because I think there's huge value to be on a motorway and being able to drive hands-free for a certain amount of time. So this is the kind of capability. And the other aspect is, especially in the high-end brands, many of the cars bought and are on the street are company cars. And very often these company cars are not equipped to the level that I would like to have it when it were my car. Right? So I can buy a used car and upgrade it after buying it. And that is fantastic, right? I mean, so having the ability to upgrade a vehicle after I basically have configured it 2-3 years later when it is sold as a used car, I think is a great option, because the sustainability aspect is important, and you always have the latest capability and upgradability to the car. It's a bit like a mobile phone, essentially. You add the apps that you need and buy for them, and I think that's a great service provided by the car maker.
Okay. And I'd like to add one more thing. Obviously, when we talk about the next thing, which is already happening, which is autonomous driving, that's mostly software enabled, right? And then when we think further down the line, by the way, I'm very much looking forward to the car driving me. I can relax much more. And when I can do that, then the next big topic is, what do I do? It's getting boring, right? So I want to be entertained, watch something, listen to music, play games. And so this is the next thing. So and these 2 things, autonomous driving and then entertainment while being driven, ideally, are both mostly software enabled, right? And we need software for that. And if this is the big thing that me as a customer, I'm perceiving of how smoothly, comfortably, and fast my car is getting me somewhere without me interfering very much, and then how well it's entertaining me or helping me relax, then this is all software enabled, right? So, yeah.
But being upgradable, so to say, what you meant, Hans-Jürgen, before, you need actually also the right hardware for that, I mean, life cycle of a vehicle is probably 10, 15 years or so. If someone buys a car, probably, I mean, something like that. But over this time, you need enough hardware resources actually to be able to upgrade, right? Is it in the current approach? If I look on the market, the current cars are not really able, I think. I mean, the hardware is already old when the car comes to the market. I mean,
Well,
I mean, how to deal with that?
Well, to give hardware into the vehicle or with the vehicle that is more capable than what the customer originally bought, right? So or asked for. So I think that is something that we also that we're very familiar with that when we think about computers, for example, right? There are certain type of computers which have a reputation for being like usable, very, very smoothly usable for 8, 9, 10 years, because the microcontroller platform that they have or the operating system platform that they have is very much scaling to high performance, while other platforms may not be that usable on an extended time, right? And I think that is how these platforms have to be designed. Have the right level of hardware capability, where you know that today I'm giving you hardware that is much more capable than what you actually have ordered, but it is extendable. And that extendability is basically like the aftermarket that you're after, right? It's a functionality as a service model, and I think that is something that we're very used to because we're paying money for subscription fees for streaming. We're paying for application software that we're running on our computers. So that is the model I think that we're after. And to enable that, you of course need something which is much more general purpose enabled. So in automotive, we talk about high performance computers, or high performance compute units with the zonal architectures where you're abstracting the local interconnect from the high performance requirements. So we see that also on the street as a state of the art technology. And I think that is something that, it's an investment by the car maker, but it's an investment that pays back when the subscription model and the functional upgrades basically are ordered by the client, the customer.
Okay. But wouldn't this also increase the price of the vehicles? I mean, nowadays, the vehicle, if you look on the market, I mean, the European, especially the European vehicles or cars, they're already very expensive. And if you make this upgradability available in the vehicles, then the prices will automatically increase because the hardware costs will also increase. And isn't this more, contradictory to the current situation? I mean, where the car makers have so many problems with selling cars, and increasing the hardware costs. I'm not really sure if this is the right way to go.
I think it's a trade-off, right? I mean, if you, for example, if you look at some vehicle platforms have 120 ECUs as a maximum. Right? So in a really high-end vehicle, you have many ECUs, you have many sensors, many actuators. Integrating these is not a trivial activity. So it's around the engineering. When you design the vehicle, it's also around manufacturing all these individual components, keeping them, the logistics, which version, which variant do you basically keep? Now, if you think about removing 100 ECUs out of these 120 or 150 and just having 6 makes the logistics much easier. So you can invest in getting a much higher performance hardware, which has like headroom to be upgraded, but you have fewer of them. Right? So even if you get rid of 90% of the hardware, which is an ECU, and make the remaining 10% 3 times more expensive, you're still saving a lot of money. for the hardware, but also logistics, also from the manufacturing process, from the engineering process. I think there is a trade-off point to have.
Okay, but do you see at the moment the potential in the current European OEMs that they go this way? I mean, implementing or providing upgradable hardware in the car? I mean, I don't know what the current, how it's currently, but
I think it's not upgradable hardware, but it is hardware which is providing more capability than actually is needed at the day that the vehicle is sold.
Okay. Mm-hmm. Okay, but yeah, I mean, because the current the current competition from China with the very low prices, and if we go with this strategy, for example, I don't know how this would. I mean, I don't know how the Chinese OEMs can set so low prices for actually such cars, but I think they also follow the same path, having upgradable vehicles at all that you can deploy new functionalities over time, and but yeah, the prices are obviously very low. I don't know how they do it, but for the European OEMs, I think this would be a big challenge. I mean, providing, so to say, more expensive hardware in vehicles and keeping the price low. I'm not really sure if how they can do that actually. I mean,
yeah. What we also see is, for example, that in the high-end vehicle of a specific brand that a car maker is offering, there may be 5 of these high-performance computers in order to deal with all the extra functionality like autonomous parking, or automatic parking, autonomous driving level 2 plus, etc. While on the lower level, you are basically using only 2 high-performance computers, right? So the scaling effect comes from there. And then if you put these boxes, these hardware high-performance computers into every single vehicle, then you also have scaling effects. So rather than having 100 individually different hardware ECUs, you now have 4 or 5 which are very similar, and then you're using them in all of these different hardware units or vehicles that you're selling. That's one thing. And then I think what we also should is that many of the Chinese car makers, for example, have very quick turnover times when it comes to product engineering cycle. Right, so we talk about 24 months partially. So part of their success is basically to develop and release new iterations on the vehicle models very, very quickly. So it's almost as if you do over-the-air update, but you do it with vehicle models that you're shipping. But that, of course, is also like a different development paradigm that you need to follow. And yeah, we also see that some of these car makers are reference customers to us because they're using a lot of our solutions. So we get a little bit of insight into how that basically works, but we're not able to disclose that here. Let's put it that way.
What do you think about this comment from Shahid? China used customized chips and parts. I mean, they produced customized chips, or how should we understand this? I mean, do you know anything about this approach?
Yes, yes, but again, for the purpose or for the sake of, we are not able to disclose all of that because we're working with the chip manufacturers, and we're working with the car manufacturers, and it's not only in China, but it's also, there's a lot of partnerships like with you have, I think Daimler has a stake of 15% in Atos. A chip manufacturer which creates specific microcontrollers for the SDV of the future. And the idea there, what I have read about it was not to own the complete 100% stake, but to broaden the adoption of these chips in the market, which I think is a great strategy. But that's where you get the scaling effects. If it's just one manufacturer creating one specific chip for himself, or having one specific chip for himself created, the cost of that may be much too high. Compared to making that a general market availability. So that's maybe one strategy that we also see. And then there are partnerships.
Okay. I mean, I've once heard that Tesla has, for example, started, I'm not sure if this is true, but Tesla started, for example, producing also their own hardware. I think, is this a way to go for car makers? I mean, to be more successful?
With hardware, you mean PCBs or you mean chips?
Chips, mainly chips.
It is something that we have heard of as a trend, but it is not really like broadly adopted by the market. Maybe so far, we don't know. It's a kind of a bet on the future, but so it's just like what I mentioned, Mercedes with Atos Silicon. Is one example where investing in the chip market or in chip manufacturer or chip design may help to basically adopt the technology easier and make it available easier. But we'll see where that goes, right? Because in the end, it's also like a lot of partnerships, like Qualcomm working with BMW, etc. We see that on the market. Right?
Okay, interesting. Robert, do you have any ideas on that or any thoughts?
I noticed that obviously everyone is screening this topic, SoCs, how are the others approaching it? But so far, no one ever told me what their internal strategy is. I think this is very sensitive.
Okay.
So, but obviously it's a big topic. It's a big topic.
I have a little bit off topic actually. I mean, do you see this trend of software-defined vehicle also in other domains, like software-defined something, software-defined, whatever? Is there also other sectors going this trend or following this trend, or is it just automotive at the moment?
Robert?
I'm very much focused on the automotive, but of course I hear from my colleagues that lots of software-driven topics are happening in the defense sector. But I can't tell from my own experience.
Okay. I mean, I'm just curious because this seems to be a trend in many different sectors, and I just want to know if you have any ideas. But defense, interesting. Okay, they go also the software-defined way. How is actually AI in this context? I mean, how do you see this? Because AI is at the moment also very hype, and how this will interfere with software-defined vehicles at all?
Maybe I can connect it to the software-defined defense and software-defined or AI into one pitch here. So what I learned is that there was a very interesting application where audio sensors are used, microphones in the end, and the raw system or the raw signals are used or analyzed by an AI system software in order to detect drones. Something which in the past in the defense market would have been a multi-year, design project sourced by defense contractors, etc. And now this is happening as a kind of a software-driven application, coming with very simple hardware, microphones, maybe mobile phones, or something that is just connected. You use an AI to analyze the raw audio signals, and then you have a sound-based drone detection system, something that years ago would be unthinkable. But that is a combination of technology, or two combinations of technologies, which I think are paving the way for the future, right? So AI is not the general purpose solution to every single problem, but in some aspects it can help quite a lot. Okay.
Maybe it helps kind of structure a little bit the different types of use cases for AI. So of course we have AI in the tools that we use to engineer the products. Right. So like if we talk about the software coding itself, you have vibe coding applications, right, to ideally be more efficient with your coding. And similarly, we have a lot of AI in, for example, geometry modeling, where instead of doing everything manually, you just specify some surfaces and parameters, and then the tool will generate geometries for you that are as light and stable at the same time as possible. So these are typical domain-specific AIs, right? Nothing like the large language models. They're just in those domains to optimize your models or generate stuff for you. And then we have AI, like the embedded AI for autonomous driving, but I'm not really into that, so I don't know how far they are, where they are. Then we have agentic, which is a big topic in Siemens right now. So the idea is, along these development processes with all these different disciplines, we are continuously passing forward development results, right? The software coders, they need the architecture specifications against which they develop, etc. So this data needs to be transported along the process, and agents can help in that. So currently we're looking very much into, first of all, how are you orchestrating these process agents and how we're getting them connected to the different engineering tools. So I think there are very many different scenarios for applying AI. And so I think what's most advanced at this point is probably in-domain AI. We also use it a lot, by the way, for simulation. With SDV, one of the big topics will be that we need to simulate the software behavior in very complex environments of how it interacts, the software behavior interacts with mechanical behavior in complex driving situations, for example. And then you have very big amounts of parameters that influence the actual behavior in the end of the system. So you need to reduce the order of factors, and there's reduced order modeling. And there we have a lot of AI techniques as well that really matter.
Is it in combination with virtualization, for example? Do you mean this virtualized environment, and you test the software in some kind of a virtualized environment, how it works and how it? Okay.
So you can literally like take application software and test it on your desktop. Of course, you can test it in the hardware, but there is like a much easier to scale way of doing that, which is make it in virtual representation of the vehicle, of not only one vehicle, but a combination of features like option variant aware, right? And then you're building a piece of software, and then you're testing that on scale, 100 millions of test runs a night, right? So it's like the nightly build report that we get, or that I get in the morning still from many of the products that I was responsible for, right? Where it tells this specific build failed because there was one function which was lacking integration with another function call, for example. That is like the end of the story. Validation, verification, looking at the logs, looking at the data, analyzing it, and making proposals for how to modify the code, for example, or the designs. But it also starts with writing requirements. Simple example, if you write down this function should be triggered every 50 milliseconds, and then there is an agentic eye or an AI who understands, well, isn't that a parameter? Because there's another requirement written by somebody else which sets this value to 25, not 50, but he's using the same term. And then you can assess that, and then it makes proposals for how to change the requirements so that they match basically test cases or other people's requirements. So these are very simple aids that help you to basically drive the development. It's not like you can, of course, also generate designs directly from a simple prompt. You can do that, right? But then an engineer needs to look at it, and then the validation of those design and the design output is very important, because otherwise you can just generate anything. AI sometimes hallucinates, and we don't want cars to hallucinate because some of the software functions were wrong, right? So
okay. I mean, if we consider the SDV or everything around SDV, there are a lot of also industry initiatives, like Eclipse or Sophie, or there are many Covesa and so on. Actually, are you involved in such industry initiatives in this open source sector? Do you know? I mean,
yes, we are in many, but I can't even give you a complete list of what they are. In some we are, and some we are not. So we're definitely a member of Eclipse since a long time. Eclipse SDV, I think I'm not 100% sure, but Sophie, AutoSAR, as mentioned, JT, many standards. Why? Because for us these initiatives are very important, because we strongly believe that integrating should not only happen with your own solutions, but also with other solutions, because that's the only way how our clients can get their tool flows, their end-to-end chains working successfully, right? And so that is something that we very strongly believe in. And we're open. Our tools are open, and integration is important, and standards are important because they are the backbone of these integrations.
Okay, as you're I mean, one of the founders of AutoSAR, actually. I mean, I always ask this question to some experts. I mean, AutoSAR is a quite old standard, which is well established in automotive. But if we see this in the SDV context, I mean, SDV is some kind of a disruptive change in automotive, in my opinion. and how this fits together, that AUTOSAR and this disruptive change of SDV, how this work together, or how should it work?
Okay.
I have some doubts, actually. I mean, yeah.
Well,
What do you think about that?
I can give you a very simple example. We are again. This is public because we have had press releases on it. But we're working working a lot with Infineon on the next generation of the Oryx platform, which again is like we're offering an AUTOSAR stack for that, like today, and in the future we will also support that. But the idea is that the zonal controllers, so not the high performance computers, but the zonal controllers, if they are used and if they require real-time capability, then AUTOSAR is a perfect system for that, because Linux cannot guarantee real-time capability, but AUTOSAR, the way how it is created, so I always call it a very complicated state machine where everything is predestined and pre-configured, and that makes it like real-time enabled. So you have a combination of functionality which requires a system like AUTOSAR and an operating system and the runtime environment and all of that, also in 10, 15 years. So I think it will not disappear, definitely not. But to combine both together using the network as the kind of an arbitration factor, I think that is something that we see also today. And then there's also a lot of new technology coming into the cars, like e-fuses, smart fuses, which are no longer requiring you to have, now we're going back to the electrical system, it's electrical distribution system. So instead of having a smart fuse box, you have smart fuses on the zonal controllers, so that when something happens to a sensor or an actuator or a motor, the fuse is not blowing like it used to be in the past, right? But you have a smart fuse which just says, oh, there is an overpower, I need to shut down. And then the fuse can be reactivated through software. So that is a big change. So for that, you again need like very quickly arbitrated, real-time enabled software. So that is a perfect use case for AUTOSAR.
Okay. But I mean, as far as I know, AUTOSAR Classic, for example, has also very cumbersome tooling. I mean, we talked at the beginning. I mean, Robert, and you already also told at the beginning, we were talking about how fast development should be, and SDV should be developed not like in the old world, much faster, and the value should be delivered to the customer much faster. If we see AUTOSAR and AUTOSAR projects, which is cumbersome tooling and formats, I'm not sure if this is state of the art. I mean, is there any activities, for example, to reconsider the AUTOSAR standard at all? I mean, to make it more modern, or are there any efforts there?
I mean, there is AUTOSAR Adaptive, which is very, very different. It's a service-driven, some IP-driven initiative where you basically where the software components are not configured, but they are kind of a bit like the Microsoft technology of the late 90s with .NET, right? Where the manifests, where you describe this is a functionality and it is reusable. This is the input, the output that it requires. This is what it can do. It's like an object defined, like object-driven programming, but you have a manifest which describes exactly what the functionality can deliver, what it requires. So this is basically what AUTOSAR Adaptive does. So this is something that is enabled and that we see. But to your comment, if the configuration is cumbersome, then maybe you're just using the wrong tools and the wrong stack, because there is a huge potential to generate a lot of that configuration parameters rather than having to type them in, right? And I think that is where you can optimize the development flow.
Okay, and it could be, I mean, you say also AUTOSAR project could be delivered faster.
Absolutely, right? And what it also enables you to do is things like functional safety certification are much easier to be reached, right? Because you have all these parameters, you have all the information. It's not like person-induced errors that you need to look after. If your task scheduler is always configured in the same way, there is no arbitration, there is no randomness in the process that you have. Therefore, the certification is easier.
Okay. In this context, I mean, you talked about the service-oriented architecture in SDVs and also adaptive stack, but we still have this different bus systems like CAN, LIN, and so on. Are they still relevant actually in the era of SDV, or are they old technology? I mean.
Well, they're not old technology. So I think Lin was Mentor Graphics was actually one of the inventors of Lin. So
Okay.
we can say that we have some patents there. Also something that is not very widely known. No, but Lin is a very simple single wire bus which is great for connecting sensors and actuators, right? Because the effort to do it is very, very low. CAN is still something which we will also see for quite a long time, because many of the hardware components that you have, from the door handle to unlocking or windows, etc., it would be much too expensive to have an Ethernet chip in every of these single actuators and sensors. So we will continue to see that. What definitely is changing is the way how the gateway between these different buses is changing. And we see, of course, Ethernet as the central backbone, automotive Ethernet as the backbone connecting the high performance computers. So we definitely see that CAN, LIN, these technologies are here to stay for long. But we also see a shift toward Ethernet as a technology, simply because otherwise, with the growing number of software that you have in the car, you cannot just have 50 gigabyte of software flashed into a car during the production day. If you're using the old vehicle architecture, right?
Yeah.
There must be a change, right? Because we have so much software that needs to go into the vehicle, and you just cannot afford to take the car out of production line, keep it somewhere for 3 days, put the software in. That is not practically usable. And for that, you need high-speed networks, like, for example, Ethernet, and simplifying the architecture, which is another good reason for an SDV, right?
Okay, but this, as you told, I mean, Lin and Can, if they say this signal-based communication is a very tight coupling in the architecture. I mean, and I think this makes many things very hard to decouple. And yeah, I think probably we need some kind of balance between service-oriented communication and signal-based communication. I think this will be still a challenge to find this balance, actually, where to use signal-based communication, where to use service-oriented communication. I mean, I'm curious. I mean, I think this is a big challenge for the architecture of vehicle, and it will stay also a big it's a trade-off, more or less, where you put which communication type. Yeah, let's see. I mean, you suggested actually the title of this talk, and what do you mean actually with that? I mean, SDV is not about software mostly. What do you mean by that?
Well, we haven't really talked about software a lot in our talk today, right?
Yes.
We have talked about network architecture. We have talked about, the way how the testing of the vehicle is changing, the way how the companies need to restructure, how they need to build software development, software factories, essentially. So of course it is about software, but it's also about enabling the software to be the core of the vehicle, right? Reducing the number of ECUs is a decision that needs to be taken on the architecture level. So something maybe on a system engineering level, where in Rhapsody or system engineering solutions, you predict where to allocate functions. You need to model the functions. So there is a whole enablement for becoming an SDV supplier or an SDV company that has not necessarily to do only with software. It's also around, just imagine, what do you do with all the space that you have available if you don't have 130 ECUs, but only 6? So do you make the car smaller, or do you make the comfort in the car bigger, right? The interior. So there's a lot of notion to that. It's also the logistics part of it. Which software goes into the car? You need to have over-the-air update capability. What is the strategy behind that? So it's not a simple software task. It is an ecosystem. It's a change in the way how you build the vehicles.
Okay. how will systems engineering change? I mean, the current approach and then SDV. I think there must be some change in the systems engineering of a vehicle. How this will change, and what kind of changes will be there?
That was one of the reasons why I was very happy with Hans-Jürgen's suggestion to say it's mostly software, but not only, because systems engineering is one of the topics I'm working on in the last years a lot. And if you think of systems engineering from a very generic approach, then software is a part of it. It must be a part of it. But when you look a little bit closer of what's actually happening in the companies, then we still experience a lot of siloed departments. So oftentimes you have software departments, then you have mechanical departments, EE departments. Sometimes EE and software are close, sometimes they're not. And then in the last 10 years, many of the automotive OEMs focused on multi-domain systems engineering, a la SysML. They started like, okay, let's build the vehicle architecture of all the systems in it and how they're interrelated. And then they quickly realized, wait, we already have the EE architectures. They already have a big part of the functions represented in them. So how are these two architectures fitting together? All over vehicle architectures and SysML, EE architectures. Usually the departments came around and said, we already have the architecture. Why are you starting to remodel things? And they said, well, there are functions and systems that are not represented in EE. Okay, good. So, and then the point I want to make is, I think there was a lot of different domain experts that still need to understand how the others are working and how their different approaches to modeling fit together. So what we've did in the last years a lot is looking at how do we do high-level system modeling, a la SysML, how do the EE architecture modeling guys approach things. That's where Hans-Jürgen can give a lot of expertise. And then we were discussing a lot of how these things fit together. Honestly, I don't know, like 8 years ago, there were people in the high-level SysML space, they modeled the EE architecture as a black box in the overall architecture, which doesn't make sense at all, because actually they're very much overlapping. I think it's just different perspectives of looking at the architecture. I think there are aspects that you would find in the SysML architecture, like functions that are not carried by electronical or software elements, but actually mechanical systems still. You wouldn't find them maybe in the EE architecture. And then in the EE architecture, you have things that you will never find in SysML, like signals, etc. And it's also not really clear which model comes first. I believe we should be open to mixed scenarios where these models are developed concurrently and need to be continuously aligned. So why I'm bringing all this up, we have, for all these different domains, we have different tools, right? So in our portfolio, we have tools for high-level multi-domain architecture modeling. We have tools for EE architecture modeling. And with our partnership with IBM, we have tools for software modeling. So we have all these tools. The question is, how do we integrate them? And the integrations that we build in our products, they depend on the processes that we want to be able to support, right? So on the actual scenarios. So, and this is the way we approach it, is that we have working groups talking about the methodologies and methodologies that we suggest to our customers and from which we derive requirements for our own product development, such that they enable model exchange between a SysML modeler and the EE architecture modeler, ideally bidirectional, right? And this is really a lot of work and discussions. Yeah, just a quick one. I guess Hans, you want to add?
Yeah, maybe to add one thing. I think when you, in the past, what happened very often was that system engineering was done by a certain group of people. Right. And then they delivered a PDF output, which went to the software engineers, who looked at it. It went to the electrical engineers, they looked at it, etc. So it was very often a kind of a one-way street. And I think what we have enabled now is a flow in which system engineering, software engineering, mechanical and electrical engineering and electronics engineering, they can all look at the data set and traverse and navigate through all that information that they have, because we give them an information backbone where requirements, for example, are linked to the wire that is a wire, part of a twisted pair can. Right, so it has an electrical implementation, but the CAN transmits a signal which connects to software components on different components on the vehicle, and then things like maybe the CAN is too close to a high-performance electric motor, right? And we may have some problems with EMI, electromagnetic interference, right? So that's a problem that you typically only understand very late in the development process, while when you are having a complete system engineering connected to the electrical, software, mechanical engineering, then you are able to predict what's going to happen, and you can set parameters in which some things may or may not or must not happen. And I think that is something that is quite new, right? Moving away from an architecture which is described in PowerPoint or in the Visio drawing to something that is actually navigatable, where you have traceability, linking. I think that's what's new. So in other words, system engineering expands its value to the downstream engineering if it delivers output and it can consume input from those groups, because then you're looking at the vehicle holistically, and which will reduce the number of problems that you will have to face during product design and manufacturing, right? Because you can predict what's going to happen. And if something happens, you know what's the root cause of the problem, and you can fix the root cause and not try to, as we say in German, herumdoktern on the problem, rather than fixing the source of the problem.
I mean, you mentioned traceability. Actually, this is a very, I think, in my opinion, a very crucial concept. Also for SDV, it's very important. But how do you? I mean, for example, if we consider ASPICE, it's a very common model we see in automotive. How much is ASPICE, for example, fitting in the SDV context? Is it up to date? Is it something we should use in future? What do you think about that? I mean, is it belong to the old world, or we should invent something new, or is it still, relevant? Or what do you think about that?
Well, I think it is just as relevant as agile development. It's having the best industry practice for developing things will help, simply because then you have more ability to validate that the output is correct. If it's ASPICE, if it is any standards and anything that helps to be a best practice guideline is very important and very helpful.
I read very often on LinkedIn, for example, people just bashing ASPICE. This makes us so slow. This everything is, the German OEMs lose customers because ASPICE is so cumbersome and so on. I don't know how much of this is real, or I don't know. I mean, but I read a lot of this bashing on LinkedIn. I'm not sure if this is real or just, some kind of clickbait.
Maybe I also give an opinion, but now this is a personal opinion, so not a general Siemens statement. But I mean, this is like the ISO standards for quality, right? It specifies processes that should be in place and work results that should happen along those processes. Now, it doesn't talk about the tools you're supposed to use to support these processes. Now, you can entirely be compliant with all these processes without ever using a tool, right? But probably it's going to be a lot of work if you never use a tool along the process, especially topics like traceability, from which you got there, right? Traceability is one of these things. If you first model everything and then afterwards you want to create trace links between everything, forget about it. Especially if you want to bring in configuration management and context, then it even kills company with only looking at the part bomb, right? So forget about it. It's a big issue. So I think the point I want to make is, if right now I'm not surprised that this is very cumbersome, the processes, because the tools are not integrated, and this is what Hans-Jürgen, I guess, wanted to point out as well. If you're doing systems engineering as supposed, you're never doing anything without inputs from a previous step, right? You're never doing anything somewhere out in the nowhere. You don't develop the software without knowing what hardware is going to run on which vehicle and what the specifications for that vehicle are, ideally, what the requirements are. So point I want to make is, if you really go systematically through development processes and the tools are integrated and they continuously pass on the data to the next step, and they say, hey, from the requirements that I received from tool A, I derive these functions, and then later on somebody builds parts and says this part realizes these functions, then traceability happens along the process. A former colleague of mine called it inline traceability. So basically, while you're following the process, in the end, the tools will just create the trace links along the process. But this is very visionary. We're not there yet. And as long as we're not there yet, and it's still a long way to go, honestly, it's very cumbersome. So,
but what do you think about establishing platforms for that? I mean, to making this cumbersome thing realized on a platform that people don't care so much about, how processes work. The platform provides already the environment where you set up the process already that someone has to follow. I mean, I don't know if platforms would solve this problem or part of the solution, or I don't know. I mean, I don't know otherwise how to make this cumbersome stuff more easy.
Yeah, I think so. Maybe sorry, please.
It's just a quick idea, and then I will hand over because I think we're running low on time. But one thing one thing I always say is creating that traceability is a lot of work. So build as much as possible of it in that reusable platform architecture definition. So you don't have to redo much of it when you reuse it, right? So that's already a thing. It's still going to be a lot of work, but let's say if you have a new zonal architecture with all the, not only the E specifications of that architecture, but how it relates to other systems, to requirements, to testing, etc. If you want to create that graph of interconnected knowledge, you can systematically reuse that in different vehicle projects. And that reuse can save you a lot of time, right? As long as we don't have that inline thing that I mentioned earlier, at least try to not redo it every time, right? I'm not saying people are doing it, but in some areas it's happening, right? A lot of rework. And that's really something we need to talk much more about reuse of these interconnected architectures.
I mean, on the other hand, there are many standards like the V Model XC, for example, that was issued by the Bundeswehr a couple of years ago. Autos are ISO 26262. So all of these are nothing else but standards that try to standardize the development process one way or the other, if it's for just the software or for the overall vehicle. And the benefit of those is basically that things like certification are much easier because you have to deliver a certain set of documents, and then you get the approval, the type approval for running a vehicle on a street easier because the rework that you would have to do in theory is much lower. So, and then the other part that I wanted to mention is you can also use that to your benefit, because if you're using a process or a template-driven development process that is supported by the proper tools, then it's much easier to not forget about information that you need to put into the flow, right? For example, our ALM solution, Polarion, offers a multitude of extensions. One of them is, for example, an ISO 26262 template, right? So that helps you to fill out all the information that you need in order to deliver ISO 26262 compliant certification right from the beginning, because it helps you to structure the requirements, to structure the process, the development effort. And I think that is like the right way to do it. Not try to do it later as a kind of a late in the process activity, but doing it right from the beginning. And then the other comment I wanted to make, I think nobody has not decided to buy a German car just because of A-Spice. I think it's the process for the end buyer, the end customer is not important. It's about the product. And if the product is right, then you buy the product.
Yeah, I was just bringing this because of I've read a couple of LinkedIn posts about that the the timeline of producing a car is delayed by ASPICE. You know, I've read it so often. There are so many people writing about that, and I'm not sure if this is really the real reason. I mean, this was my motivation to ask you actually this question. We are running out of time actually. Thanks, Hans-Jürgen, Robert, for this interesting interview with you guys, this event. Do you want to say some last words?
I didn't follow up if we had some comments or questions from
yeah, I mean, there are some comments, but we don't have any time, unfortunately.
Okay.
Yeah, I mean, I don't know. The 1 hour was flying. You know, I didn't notice that.
Yes.
Yeah. I have tons of questions actually in my head to ask, but yeah,
Same.
time is over, unfortunately.
No, just thank you very much for the nice discussion. I'm always up for continuation for deep dives into topics.
I mean, I would love to continue actually, especially this inline traceability you talked about. That I would be very interested in that to go more deeper in that. I think traceability, as I told you, is one of the key concepts in SDV. If this is not established properly, I think we will have a lot of problems. And this inline traceability seems to be a very interesting concept. I mean, probably we can have an episode on that in future.
No, would be great. Well, it was great to be here and great to have this activity. It's always fantastic. For me, it's fascinating to talk about SDV because it is a topic that never amazes me. Never stops amazing me. How quickly we make we succeed in that, and great.
Thank you so much. Thank you so much for the questions, and thank you so much for this interesting episode. See you next time then. Bye.
Thank you, everyone. Have a great evening.